Cisco Certified Network Associate Day 27. Welcome everybody, I'm Imran Rafai, your trainer for this entire series. Today we're going to learn about ACL or Access Control List, and we will take this in two videos. We'll have day 27, which will be looking at ACL introduction, and we will look at configuration of standard access list. And day 28, that's the next video, we will have extended access list, right? So without wasting much time, let's get straight into today's class. And before we go any further, let me give you some social media contacts where you can contact us to get information and questions answered, right? So that's listed here, and please feel free to contact us. What are we going to look at today? Today we're going to look at three things. What is ACL? We'll differentiate between standard ACLs and extended ACLs, and then we will try to configure standard ACL. We'll have a lab task, right? We'll have few tasks and we'll configure standard ACLs, and we'll try to troubleshoot. So what is ACL? If you followed us from day one, all the information on all the videos built our knowledge to come to a stage where we were trying to establish communication between devices, right? So we learned about routing protocols, we learned about static routing with different routing protocols, and the aim all the while was to make sure that we ensure communication between devices in the network. Now we have reached a stage in our journey in learning the topics on CCNA, or in achieving the CCNA certification, where we have to learn about controlling the flow of traffic, right? So sometimes we don't want the bad guys you can't really call them bad guys, unauthorized people. Like for instance, in sales, we have people in sales. Let's say this is a sales network. So in this diagram, this is an example. We have four networks. You have the sales network, accounts network. So the sales network is here. Then you have accounts network at the top. So this is accounts. Then you have management, right? And of course we have the server room, right? Now we don't want everybody in the sales team, right? Sales, we might have hundreds of new hires, right? And we don't want everybody in this team to access server, right? But let's say this laptop too, let's assume he's the manager, right? So the manager needs access, right? So if the manager wants to go to server, absolutely fine, that should go through. But if there's a new hire guy, and he doesn't need to access the server, right? So you don't want, if he's trying to access, the traffic should be dropped and he should not get access to this thing. So this ACL, right? ACL is a mechanism by which we can filter traffic depending on their different parameters. We can filter them according to their source IP address, destination IP address, the protocols, port numbers, different mechanisms by which we can identify traffic and then take action on them, right? So ACL is a layer 3 filter mechanism. That means the filter is going to be applied in the routers. So in this case we have two routers. So the most important thing when you're doing traffic filtering is to identify the data flow. So for instance, in this case, if you want to block this guy, right, laptop 3, from accessing server, we need to first identify the traffic, right? So if this guy was communicating with the server room, like for instance server 1, the ideal flow of traffic is going to be to the switch to the router, then from router to this router, then to the switch, and then here, right? This is the data flow. So we need to first identify the data flow, and data flow, we see that the packet is going through this interface, coming out of this interface, again entering this interface and getting out of this interface, right? This interface has nothing to do with it, and this interface has nothing to do with it, right? So we need to identify the traffic. Once we identify the path, we can decide where we need to apply that filter, right? Don't worry about the filter. What and how the filter is applied, that's all secondary. We'll learn in the next slide. But for this slide, the main thing that you need to understand is we need to identify the flow of traffic. Once we identify the flow of traffic, we can put the relevant filters in these interfaces, right? ACLs are applied on the interfaces. Like for instance, let's have a closer look. Before that, let me just clear all the markings on the slides here. So every time there is a data flow, there is one interface through which the data enters, or the packet enters, and there's another interface through which the packet exits, right? So there are three places basically. One is the in interface, one is the out interface, and one is the router itself. Just remember, ACL filters can be applied on interface while coming in, right, in direction, or while going out. That means when a packet comes in, this interface will look at the parameters through which you want to match, right? Like ACL is basically, I mean, if you think about ACLs, it is like you have these guest only, invite only events, and all these invite only events, you will have somebody at the gate who looks at a guest list, and only people who are part of that guest list are allowed inside, right? So similarly, ACL is a list, a qualifying list. You put all the qualifying parameters. Like I said, don't worry about those parameters and how. We'll discuss that. I'm just giving you a basic idea that it's going to be a list. This list is going to identify the traffic. We'll say every traffic coming from 192.168.1.10, right, permit it, and every other traffic, deny it. So you're just given a list which is going to identify the traffic. So anytime the traffic is coming from 192.168.1.10, this access list is hit. So basically you can put those access lists, you can apply those ACLs either in the entry interface or the exit interface, right? Just remember that. So like I said, ACL is a list which is used to filter traffic. So let's look at slightly advanced. I mean, let's look what ACLs are. So there are two types of ACLs. One is standard ACL, right? Standard ACL are ACLs which has identification numbers of 1 to 99, or 1300 to 1999, right? What are these numbers? These are just names or just identifying numbers, right? They have nothing to do with a priority, just because standard ACL 1 has no more priority than standard ACL 2, right? This is just the name. We can also have a name, so you can just have a regular name for these access lists. That's also possible. Similarly, standard ACLs, extended ACLs are ACLs with numbers 100 to 199 and 2000 to 2699, or of course you can have a named version of these ACLs as well. If it's standard ACL, the classification is happening based on source IP address, right? So every time you put standard ACL, you're making use of standard ACL, you can't stop traffic depending on the destination. So you can't put a standard ACL and tell that block all the traffic going to a certain destination. You can only tell if it's coming from a certain destination, right? So standard ACL is always based on source IP address. But on the other hand, extended ACLs can be classified based on source IP address. You can say destination IP address. You can say going to this destination, you block that. You can look at protocol. You say, okay, only TCP. I mean, you can say only FTP, block only FTP traffic, or block only HTTP traffic. You can also look at the protocol that it is using and block only those specific things. That's extended ACL, right? So in this example, or in this video, we're only going to look at standard ACL. We will look at extended ACL tomorrow or the next video. Let's have a general guidelines of ACLs. So ACL, like I said, is a list of conditions. So it's like the guest list. You have a list, you write those lists, and once you apply that to either the in interface or the out interface of a router, it is going to look at that list, and if there is a matching condition, it is going to take action, right? So if you write an ACL in your router, and if you don't apply it, it is like creating that list and keeping it in your office. You apply it that is when you actually send a security guard or whoever to stand at the entrance. So if you're applying it to the inbound interface, then it's like you're looking at all the guests coming in and you're looking, comparing them with your guest list. And if they're not part of the guest list, you're not letting them get in. Similarly, you can also put another like you can also put it under the outside interface, for instance outside direction. I mean, people get confused of in and out in routers, but like I said, it all depends on your data flow. So if you identify the data flow, you know which is the in interface according to your flow diagram, like I discussed, that if there is a router here, if the traffic flow is like this, right, then this is the in interface, or I mean, it's not the interface that is in. Basically, you're telling that apply this ACL on the in direction in this interface, right? So if this is F0/0 and F0/1, you're telling in F0/0 apply this ACL for all incoming traffic, right? So if you apply this ACL in the outgoing traffic, then all the traffic coming in is not going to be checked, because you are only checking in outgoing on F0/0, right? So don't get confused with in direction and out direction. That is depending on the flow of traffic. So first you need to identify the flow of traffic before you can think what is the right application. Should we apply incoming traffic, or you should apply outgoing traffic, right? So that's what ACL is. ACL is a list of condition. So your list of condition could be source, if traffic coming from source, please permit, or so traffic going to certain destination, deny, right? Whatever. So after you identify the condition, there are only two possible actions. You can say permit or deny, right? So you can say permit traffic going to 192.168.1.30 and deny packet going to 192.168.1.10, right? So you only can either put permit or deny, right? So you can have multiple. In one ACL you can have multiple lists, right? Multiple number of conditions, but each of those conditions has to be a permit or a deny. Now, like I said, if let's say there are deny something, permit something, right, and deny something. Now every time a traffic comes in, it's going to check the first condition. Is it matching? No. Then it goes to the second. Is it matching? No. If it checks the third condition, is it matching? Yes. If it matches, it stops immediately there. It doesn't go below that, right? So whenever that match is found, right, firstly it will start comparing from top to bottom, right? So that's how it is. But once that match is found, it doesn't do any more further. It doesn't compare the conditions that is following, right? So it stops there, and it takes action depending on permit or deny, and then it goes to the next traffic and starts from the beginning all over again. So only once it does, right? So once a match is found, that's it, done. They discard or permit that traffic, and then they go to the next traffic. And also, whenever you write an ACL, there is an implicit deny all traffic at the end, right? That means if let's say you have permit conditions, right, or let's say for instance you say I'm going to deny traffic 192.168.1.1, and you're just going to put one line in your ACL, deny traffic 1.30, right, and everything else you want to be permitted. So you're just putting this deny one command, and you're thinking, okay, I'm just denying 1.30, but everything else will be allowed. No, you're wrong, because at the bottom of all ACL there is a deny any command. I mean, you may not see it in your running protocol, or if you run your access list, if you look at it, you will not see it. But just know that by default, every ACL has an implicit deny at the end. Now, the condition for this implicit deny to take effect is that you need to have at least one user-defined list, right? So, if at all you've just create an ACL and you have not put any statement in your ACL, then this implicit deny is not going to work. But the minute you put one of the user defined rule, so you say deny 192.168.1.30, at the bottom a deny any is already also there. So if your condition is you have to deny only this but you have to allow all other traffic, you have to put another statement after this statement saying permit any. That means that everything other than this is going to be permitted by default, right? So that's another thing that we need to be careful. Now this is a general rule. If it is standard ACL, apply it as close as possible to the destination. If it is extended ACL, apply it as close as possible to the source, right? An easy way to remember that is if you remember these statements: standard, destination, and extended source. So you I mean, this is something I recently read. You cannot have two S's in either of these statements. So standard at source, if you say, you can see there are two S's. That is wrong. Standard is at destination, extended is close to the source. Now this is what Cisco says, and if you in practical life you will have many cases where you're not following this very strictly. You would be putting a standard ACL close to the source, but according to Cisco, this is what it is. So if at all you have this question in your exam, in your CCNA test, please follow what Cisco is asking you, because Cisco is only going to look at what Cisco is asking you to do, right? Even if you know that the answer could be wrong, right? In real life you're using it differently, don't worry about it. Standard is always closer to the destination and extended is closer to the source. Let's look at the standard ACL syntax, right? So there are two ways of defining your ACL. One is a classic way, where you say in your global config mode, you say access list and you put an access list number. Now if you remember from our previous slide, it said any number from 1 to 99. So if you put access list and you put any number from 1 to 99, automatically your device is going to know that this is a standard ACL, right? And if you put any number from 100 to 199, it automatically knows that you're doing an extended ACL, right? For this video we're going to do standard ACL, so you can put any number from 1 to 199 or 1 to 99, and then you can put a statement deny or permit. So if you say deny, it denies whatever matching parameter is going to come here, or you say permit, it's going to permit whatever is there. So if you have 100 lines, you have to type this entire thing. So access list 10 deny matching parameter, then again access list 10, you have to put the same number if you want it to be part of the same access list, right? And then put the parameter. Matching parameters, just a minute, I'm going to come back to matching parameters because you have a matching parameter here, so we'll discuss that together. So the modern way of doing it is you come to global config and you say IP and you say access list, then you put the keyword standard. If you're doing extended, you put the keyword extended. So in this case it's going to be standard, so IP access list standard, and then you can give an ACL number, again 1 to 99, or you can give a name. You can say access list NetworKing, right? So whatever, IP access list standard, NetworKing, whatever that name, that's the identifier. Immediately it goes into a sub command or sub configuration mode. Then you have to individually start putting your deny and matching parameters or permit and matching parameters, right? The modern way has a lot of benefit over the classic way. Like for instance, in classic way, if you type, let's say access list 10 deny something, access list 10 permit something, and then after typing 20 in the same access list, after typing 20 parameters, you realize you have a change, you have to change something. You can't change, you have to delete this entire access list. The minute you say no access list 10, all the 100 command is going to get deleted. There is no way of editing it, right? So that's the worst, that's a bad part. But in the modern syntax, you have these statements. What happens every time you enter a statement, it says the first command that you type gets sequence number 10, and then say deny whatever. You don't have to put this 10, it automatically comes in there. The second statement you put, it has a sequence statement 20, right? It goes on. Now for instance, in between 10 and 20 you want to have one, like I said, it's always sequence order, right? So sometimes you need, the order is very, very important, right? So if you want something to come in between these, you could come in and manually put a sequence number 15 and say deny, and that is going to come in between there, right? Or you can just say delete 20. You have 30, 40, 50. You can say delete 20, right? This line gets deleted, and you can add another 20, and then you can put thing. So there are different ways of editing using the modern syntax, which is not available in the classic syntax. Another thing which I forgot to tell is when you're planning your access list ACLs, you need to be very careful, because like I said, if it is coming from top to bottom, right, if it starts with the first command and checks that, then goes to second command, third command, so it's always best to be very specific. Let's say for instance there's a host that you want to allow, right, so you're going to put that first, the host one, because that's specific, one host we're talking about. And then if you want to, like, let's say for instance you're permitting host, right, permit one host, and you want to deny the entire network, right? So network is like the whole thing, right, but this one host is more specific. So always put the specific ones at the top and the general ones at the bottom, and that's the best way, so that you do not have problems. Otherwise you're going to have a lot of problem with your thing. So always remember, specific conditions should be at the top and general conditions should go at the bottom. So once we create an access list using either of these way, either the classic way or the modern way, you have to apply this ACL. Now how do you apply that? You go into the interface, just like normal interface F0/0, whatever, go into the interface subcommand and type this keyword IP access group. Remember this access group, this is access list. So access group is what it's a keyword used to apply this to the interface. So once you go into that interface, whichever interface, depending on your task, you identify the data flow for that traffic, what you're trying to filter, and then you also know whether it's inbound traffic is inbound at that interface or is it outbound on that interface. So depending on that, we need to come here, put the ACL name. So for instance, this is IP access list standard and networking. Then you're going to say IP access group networking, and then you're going to apply this in the inbound direction or in the outbound direction. Right? Just think about the security guard. You're going to keep him there checking for people coming into the building, or you're going to keep him there to check people going out of the building, right? So ACL is the guest list or whatever that list he's holding. If you apply it, that's when you're asking him to go stand there and filter people in the inbound direction or the outbound direction, right? Now let's take a task, right? And we're trying to work this. As we go, we'll try to work this, and then of course we'll implement this on packet tracer, right? So this computer, now we have 4 network like we discussed. We have sales, right, and we have accounts, we have management, and then we have a server room. First task, all traffic from accounts or sales, that means from this part, going to management or server room must be blocked, right? So this traffic coming in from here and going here, and this traffic coming in and going here, we need to block this here. So if I put that, if let's say for instance, first let's create the ACL. Now the ACL, it says deny 192.168.1.128, right? Deny 192.168.1.128/26, that is this one. If you see the entire accounts network /26, or it says deny 192.168.1.0/25, which is the entire sales network. So we're saying deny this entire network and deny this entire network and permit any. Why did I have this permit any? Like we discussed, without that everything will get denied because there is an implicit deny at the bottom. So we're saying everything else, right, should be permitted, but in this case there's nothing else on this router. These are only 2 traffic, but don't worry, because that's how we do it that way. So we say permit any. Now where do we apply? Can I apply it in G0/0? I could, but if I applied this access list on that, only accounts traffic will get blocked. I can apply it on G0/1, but only this traffic. Like I said, in standard ACL, we're looking at standard ACLs, right? Standard ACL only source IP address. What it literally means by this statement is deny every traffic coming from this network. So if I put that in G0/1, G0/0, it is going to block this traffic. If I put it here, it's going to block this traffic, but then what we need to do is we'll have to create two access lists and separately put it. But when we are combining these statements in one access list, the only place where both these traffic get in is either here or here, right? But according to our rule, standard ACLs must be applied closer to the destination, so ideally it should be applied here, but I like applying it closer because I'm avoiding, I mean, like I said, in your network you have to avoid traffic, right? You don't want the same traffic to reach all the way here for this router to take decision and saying, okay, you guys are blocked. I can block it here as well. I can go to the out interface in S0/1.0 on router 2 and say everything going out, block it. So I'm going to apply this secure MA and SE, right? Secure management and server. That's what this name means. I'm going to apply that in the outside interface of S0/1/0, right? That's task 1. Again, another thing I actually forgot to tell when we're talking about parameters is okay, I'm just going to quickly go back. Yeah, matching parameters. So matching parameters, you can say any, right? So when I say IP access list, ACL number, permit or deny any, that means every traffic is allowed or denied depending on that. Then we can do is we can say host, right? We can say host and we can give the host ID 192.168.10, whatever that IP address, and it's going to permit or deny only that host. The next thing that you can give is the IP address itself. So you can say 192.168.1.10, right? And let's assume this is a network /24, right? So /24 has a subnet mask of 255.255.255.0, right? This is a subnet mask, but you can't put subnet mask. If you're doing access list, there is a new concept called wildcard mask, right? So you need to put in your matching parameters, you need to put the network ID, right? Let's say in this case it's going to be 0, so 192.168.1.0/24, right? So you're going to put the network ID and you're going to put the subnet mask. So how do I get the subnet mask, wildcard mask? How do I get the wildcard mask for a specific subnet? You say 255.255.255.255, all 255. From that, minus your subnet mask. So 255.255.255.255, this is 0, this is 0, this is 0, and this is 255, right? So the wildcard mask that you're going to apply for this access list is, so you're going to put IP access list or whatever that you're using. In the matching parameters, you're going to put deny 192.168.1.0 0.0.0.255, which means to say, so how it works is like this: wherever there is a 0 in wildcard mask, right, it is going to match. Wherever there is 255, it's not going to match. That means it's only going to see the traffic is 192.168.1, and it could be anything 1.1, 2, 3, 4, 5, doesn't matter. If this part wherever it is 0 matches, that is going to match. So it's a, if you have said 190, if you had said deny 192.168.1.0 0.0.0.255, any traffic from 192.168.1 will get denied or permitted depending on your statement. So that's an easy way of wildcard mask, and we'll come back to wildcard mask a lot better. Maybe I will try to explain it much better. I should have planned for it here. I should have got the slides. Anyway, I'm going to put a much better explanation on this wildcard mask in the next video when we're explaining extended ACLs, right? And also wildcard mask is going to be used for a lot of purposes. So wildcard mask is going to come in ICND2 when we do OSPF and all the, I mean, we are going to come back to wildcard mask in a big way in a very long time. Another thing is that I've forgotten to mention about ACL. ACL is not only about filtering permit and deny. That's just one aspect. There are so many other things an ACL can do. I mean, ACL is used for encrypting traffic in VPN, even policy-based routing. You can use ACL. There are so many things ACL can do. But for your CCNA, it's going to be very generic. So it's just about filtering traffic, right? So we're only going to look at ACL in from a CCNA perspective, which is going to be filtering traffic. So yeah, we looked at this. Task 1 said all traffic from accounts and sales going to management and server room should be blocked. So that is done using this ACL. And don't worry about this ACL. This is not the format. Of course, we looked at the format. That this is just for us to understand, right? So that's why I've written it in this format. We will be putting it in proper format when we start doing it in Packet Tracer. Task 2 says server room can access all hosts except hosts in management, right? I'm gonna quickly clear the screens. Okay, that means server room can access anything here or here, but it will not be able to access management, right? So what is it? Let's look at the data flow for, let's say, if server room. And when I say server room, it could be like an IT administrator sitting in the server room. So we don't want to access the IT administrator to access management by default. Only if there's something critical, the IT personnel can go to the management's computer and solve it. But I mean, we don't want any traffic to come into management from the server. Anyway, I mean, don't go by the task. This task is not a practical task, so it may not make sense why server and management room is not communicating. This is just a learning task, so we're just trying to just give some random tasks so that we learn, right? So don't get into the nitty-gritty and ask me question why a server will not access management. We're not bothered about that. We're only bothered about the ways by which we can actually filter traffic, right? So first, let's identify the data flow path. Data flow path for server to communicate to management is this. That means goes through G0/1 of R1 and then gets out of G0/0 of R1, right? So if I'm going to put a standard ACL which says block deny 192.168.192, and if I put it in G0/1, what will happen? Like I said, standard ACL is source IP address. So every traffic, even traffic that is going to accounts, it will still have source IP address as this one, 192.168.192. Anything that is going to sales, that also will have source IP address 192.168.192. So if I apply an access list, and let's say the access list is this, deny 192.168.1.192, which is this whole network. If I put it in G0/1, all traffic going to even accounts and sales also will get dropped. That's not what we want. We want only traffic going to management. So the ideal way or ideal place that we have to put this access list is G0/0 in the outbound direction, right? So don't get confused with the direction. It's just a matter of data flow. In this case, we know the data is flowing like this. So the only way the traffic would get interpreted is in this interface in the outbound direction. So the traffic is going to come to this interface, and it sees that okay, you're going to, your source IP address is 192.168.192, which is matching my ACL list. So I'm going to deny because that's the action given here. Any other traffic, if let's say the traffic is actually coming from accounts, it is, and if I applied here, it will say no, your IP address, I mean your source IP address is 192.168.1.128 range, whatever that range is. It says no, I don't have a list which says deny, so you are permitted to go, right? But it's a different story that because of our first ACL which is applied here, all traffic coming in from sales or accounts is anyway going to be dropped here, right? So that's our task 2. Task 2 is done. Next, let's look at task 3, which says laptop 3 from sales, which is here, should not be able to access anything outside the sales LAN. So let's assume this guy is a new guy and he's a trainee, so you don't want him to access anybody else outside the network. So we have to put an ACL. The ideal place for this ACL is here, because when it sees that the source IP address is 192 whatever this IP address is. Let's assume this is I think 1.3. So if it says the source IP address is 192.168.1.3, please deny it. So it stops that traffic, and this device will not be able to, and it says permit all. So if laptop 2 wants to communicate, that ACL has no effect, right? It can, because of this filter, this cannot go outside, but it definitely can go to the account. So he can communicate to accounts, no problem, because this ACL will not block it because he is not filtered. It's only filtered for 192.168.1.3, right? So the next thing is task 4. It says PC0 from accounts, right? PC0 from account. This guy, I'm going to quickly clear the screens, becomes easy. PC0 from accounts should be able to access server room. So he should be able to access server room, but he should not be able to access management, right? Now if you remember our ACL here, right, this ACL is going to block all traffic here, right? This is a wall here, and it's going to block all traffic. But because our task is asking us to allow only this computer to go through, we need to make an exception, right? So this is one of the reasons that if at all there is a task given to you, it's best not to start off typing it onto a live router or on your network or anything. It's best to always take a pen and paper, or maybe take notepad in your computer and start typing it, because you might have to change. And okay, in this case we are using the modern way, so it's much more easier for us to, let's say we have put these 3 statements, and I mean, what happens in this case if I want to put an exception for this 192.168.1.28, and if I add one more statement normally without making any exceptions, that is going to go here. That's going to be the 4th statement. The first statement says 192.168.1.128 deny, and this computer is part of that, and this is going to get denied, and that's it. The ACL is not going to be checked below that, right? So ideally this specific, now this is for the whole network, and this is for this specific computer where I want a permit. So ideally this computer 192.168, right, because of this deny statement will not go. Ideally I want that permit statement, because this I want it to be permitted, I want that permit statement to go first before the deny statement. So this is a specific what is that specific command, and these are the generic commands. So always a specific needs to go on top. So if it's modern ACL, of course it's easy for you to go edit that and add this as the first command, but if you had used the ACL the classic way, it becomes difficult. You will have to actually delete all these 4 commands and then start typing all these 4 commands again, right? I mean earlier the 3, so you'll have to delete all the 3 commands and then start typing these commands. So you start with permit and stuff, right? So these are the 4 tasks we need to access. So once you put this permit statement, what happens is, first it's going to check this. So if at all this computer is communicating, it's going to check this, and it says permit 192.168.1.30, which is this computer. This is 1.30, and that's fine. But if this computer communicates, it checks, is it permit? No. Is it this? It says yes, you're on deny statement, because the whole network is on deny statement. So this computer gets blocked here, right? So I think we have done all these 4 tasks. Now what we're going to do is we're going to go to packet tracer and configure these there. Alright, so I have built the same network that you saw on the slide. I've also numbered these IP addresses, because in our presentation it was not very clear. So now it becomes more easy for you. You know what are the IP addresses, right? And what I've done is I have configured these IP addresses on all these devices, and I'm running RIP on these routers. So basically there is communication between all the devices now. So I can communicate from sales to server, sales to management, sales to account. Everything is working like you normally do. But since we are an ACL, we have to start filtering traffic, right? So the first thing is I need to create, like for instance, I'm going to start from here, and I'm going to go here. I'm going to try pinging 192.168.1.194, which is server 0 of the server room. And what happens? Does it ping? So I'm sure it's, yeah. So it is perfectly working, absolutely fine, no problem at all. Similarly, I'm going to ping 226, which is the management laptop, and that also should work because routing is working, like I said. Of course, it's going to take time because of ARP, and it's going to be the first ping is going to always fail because of ARP, right? So now what we're going to do is we are going to filter traffic. So I'm going to go into the router, okay, and okay, this is where the router is. Okay, so I'm going to go into global config mode, right, and I'm going to create an access list. Now I'm going to take the modern way because this is the modern way. We will use the classic way here for ACL 10, right? So the modern way is IP access list, right? I'm going to put question mark standard, then question mark 1 to 99 or word, but we're going to do word because this is what we want in our in our solution. We have put a name, so I'm going to put the same name. We're going to follow that same solution that we did on paper. Secure MAANDSE, right? Now here I can say deny, permit, I can put remark, I can say no, I can put default, and I can put a sequence number. Like I said, if I don't put a sequence number, it is automatically going to create a sequence number, so I'm not going to put a sequence number. I'm going to say permit 192.168.1.130, right? I'm gonna, this is a host, right? So what I can do is I can say permit, and I can say host, and then I can type 192.168.1.130. This is perfectly fine. I can hit enter. This is valid. Or I can put the wildcard mask. So this time I'm going to do this. I'm going to show the wildcard mask a little later, in I think when I do the next one, right? So we've done permitting host. Let's say deny. We say deny 192.168.1.128. Then this is /26. So when it is /26, what is the subnet mask? It's 255.255.255.192, right? So we can take a calculator. If we delete 255 minus 192, our answer is 63. So our wildcard mask should be 0.0.0.63, right? That means now I have this network /26 I have denied. Similarly, deny 192.168.1.0, and this is /25. /25 is 255.255.255.128, right? So if it is that, the wildcard mask is 0.0.0.127, right? So I have denied everything, and I need to permit everything else. Remember, permit any has to be there, otherwise it's going to deny every other traffic. So I'm going to say permit any, right? That means it has permitted all of the traffic other than this. Now I'm going to apply this. Where do I apply? Apply in the out interface. So interface S0/1.1/0. I say IP access group, right? IP access group, and I'm going to tell the word. The word here is secure MAANDSE, right? Sorry, and we need to give the direction. So once I do that, we need to tell whether it is in or out. It is going to be out direction, right? So any traffic now going out with, if it matches here, it is going to be filtered. So now let's do this. Let's go here and try to ping this device, and ping 192.168.1.194, and it will ping because we have specifically permitted that 192.168.1.30, which is this computer. We have told that it can access the server from this computer. If we try pinging the old thing, we've tried this earlier and it worked. Now when I try, it says destination host not reachable. Even if I try pinging the one before that, 194, which is the server room, it is going to say the same thing. What we can do is we can go and check. So if I do this, show IP access list, it is going to tell IP access list secure MASE is in place, and 10, that is permit host. Remember the sequence numbers, like I said, 10, 20, 30, 40. Permit host 192.168.30 has been matched 24 times, which we saw. We tried that and it hit. Deny, it denied it 8 times because we tried it a couple of times and it denied it, right? It was going from here, it denied that. So it's going to tell how many times it was matched and how many times it prevented it from doing. So that's a good thing. We can always come here and look at the access list. So our task 1 is done. Basically task 1 and task 4 is done because we put this access list there. A second thing is let me show you one more thing here. So if I want to make some changes here, I can come here, configure terminal, and put the same IP access list, standard secure MAANDSE, and I can say no permit host 192.168.1.130, right? And if I go do show IP access list, you will see that that one is gone. I mean, you can edit it on the fly. It's very, very easy, which is not the case with the classic one. We will be seeing that very soon. So now let's create this, because this is also in R2. So I'm going to say any traffic that is going from laptop 3, right? Now because of this filter secure MAC, none of the traffic can go out to this part, management or server room, but laptop 2 from sales should be able to communicate with accounts, no problem, right? So I'm going to quickly check that. Ping 192.168.1.131, it's working. And even this computer, ping 192.168.1.130, it's working. Now we don't want this computer, this particular computer, right, laptop 3, we don't want it to communicate outside. It can only communicate with laptop 2 in this network. It can't go out. So we need to go create an ACL. So what we're going to do is this time is create a class, create an access list using the classic method, right? So I'm going to go put back this command actually. So now if I put, okay, now another thing, now if I put permit, going back to this ACL secure MA, I've deleted it. Now I'm going to add it back. Now if I do this, you can see that the permit ACL has come at the bottom, and it's of no use. It will not work because this traffic will definitely get even 130 traffic going from here, which is one of our tasks, from 130, like you can go check again. Now it will say destination host unreachable, because now the first statement is deny. So this whole network is on deny. So even if there is a permit statement towards the end, it's of no use because it's getting denied. So what you have to do is, if you want to edit an existing list, now I will go say no permit host, which means again you will see that it is gone, and I can say 10. I can put a sequence number here, so I'll say 10 permit host 192.168. So now if I say do show host, you can see that this has come up. So you can because of the sequence number, you can play with it such that you can actually change the order much more easier compared to the classic way. You'll see the classic way now. So let's create this ACL 10. The classic way is access list, then I put a number, I said 10, and here I say deny or permit. So I said deny 192. We need to say host, basically, either host, or you can say IP address. So I'm going to type the IP address way 192.168.1.3. and what is the wildcard mask? Because if it's a host, the subnet mask is 255.255.255.255, all 255. The wildcard mask is inverse of it, which means 255.255.255.255 minus your subnet mask. So in this case, it's going to be 0.0.0.0, right? And I hit enter. So I'm going to say access list, deny this 1.3, and then I need to say permit. So I'm going to say access list 10. I'm going to put the same number to tell that this is part of the same access list. Permit any. Now, where do I apply it? I have to apply it in the interface G0/1, right? So interface G0/1, IP access group, the way you apply is the same. Whichever way you create the access list, it doesn't matter. You apply using the same command, IP access group, and you say 10, right? And you're saying whether it's in or out. In this case, it's in, and I've applied it. Now, can this device ping outside the network? This is laptop 3. I try to ping. It says destination host unreachable. So there are two ways of finding. One is show IP access list and show access list. Both are the same. One is a new way, one is an old way, right? So it does not matter. Both of them will actually show you the same result, right? So we have done our task. There's one more task. We need to put this. So we'll go here and we create an access list. So we enter configure terminal IP access list standard, and you say secure MA from SE, deny 192.168.1.192, right? 192, and the subnet mask is /27. So subnet mask is 255.255.255. If it is /27, it is 128.192.224. So we do 255 divided by 224, right? 255, minus 224, which is 31. So we say your wildcard mask is 0.0.0.31, right? And you say permit any. So all the other traffic is permitted. We say interface G0/0 IP access group secure MA from SE. Inbound or outbound, we say outbound, right? Now this device, right, the server, and if I try to ping 192.168.1.226, which is management, it should not work. But if I try 1.130, it should work, right? So it's working. It is not letting it go to this management. It's going to let it will definitely let it go everywhere else, right? So our task, according to what we wanted in our task, we have achieved all those tasks. So critical thing that we need to understand is again, let me just show you this one last time. So we go here, the classic form, right? So there are two ACLs. So I go into this. So access list, if I want to modify access list 10, right? How do I modify access list 10? So this is the classic way, right? You have 10 and you have 20. We can't, I mean, if you look at do show run, we see that access list is given here. So this is the this is the access list. This is the modern way of doing it. So you can see IP access list, and these are sub commands. But access list 10, because you formed it in this classic way, you have multiple lines which says access list 10 deny, access list 10 permit, right? So now if I want to make any changes, I have to say no access list. Let's say I want to delete this part, access list 10 deny host, and then I want, let's say, I mean in this case there are only two. Let's say there are access list 10 and there are 20 commands here, different networks, and you want to just delete one. The minute I say no access list 10, and let's say I'm saying deny host, I'm just copying this whole thing, thinking that I'm going to delete only that one line, right? Only this one line. So I'm going to say no access list 10 deny host this thing, and I hit enter, and see what happens immediately. This whole access list 10 has disappeared. That access list 10 no longer exists in your router now, right? So that's why the classic way is difficult to edit. The modern way is much easier because you can change it, right? So I think that concludes this video. We have looked at ACLs. I know there are a lot of theory in today's class. The best way is, I would suggest all of you to go through this video maybe one more time, get hands-on experience. I mean, just go through the video and try to practice as you watch the videos, because ACL is a very important topic. I mean, it is confusing to say the least. People get confused with a lot of things, the wildcard mask, how do you apply it. I mean, it's very daunting, but trust me, it's not that difficult. It's very easy. You just have to get the concept, just grasp the concept, and I think I've tried to make it very simple. Watch it maybe a couple of times, you will have an idea. And the most important part, like I said, is practice. There's nothing like practice. And CCNA, you need to know the concepts, and you will know the concepts only if you start practicing. Make those mistakes, don't worry, this is not your exam. When you practice, I mean, don't practice in such a way that you just look at my command and just copy paste it. No, that's not how you practice. You take the task, try to understand the question in your own way, and from the knowledge that you already have, try to deduce the answers, right? You try to deduce the answer. You would say, okay, if I have to block traffic flowing from here to here, what do I do? Where do I apply, right? So you deduce it and you try doing it your own way, and then you will come up with your own shortcuts for your mind, for your brain to remember those commands, right? So all the best. Don't worry, we'll be coming back very soon, and we'll do the extended access list. I think we are reaching the end of ICND1. We are covering almost all the topics. I mean, we have maybe a couple of more topics, maybe NAT. Yeah, I think PAT, NAT, and extended ACLs, and then we're going to look at the syllabus of ICND1, and if there are any topics that we're not covered, we'll be covering in a filler video that is going to come. So thank you for watching, and I'll see you very soon. Bye bye.